So today we are going to solve a problem of a famous question which is about combination sum. In this question we have given an array which is about candidate name and there is a target. So what we need to return, we have written different combination whose sum equal to 7. Like here there is two combination which is equal this and this. This sum equal to 7 and this is also 7. And we can choose any number, unlimited number of times, like there is mentioned here. We can choose 2 to any number of time. We can choose infinite number of time, and 3 also. We can choose infinite number of time. But we cannot return two duplicate subset. What exactly two duplicate? I will tell. For example, there is a combination is 2 2 3, and there is other combination which is 3 2 2 2, or either we can say 2 3 2. In both three subset, I can say in both three the subarray you can choose only one, because these all are duplicate. You can either choose this one, or this one. You can't choose all three. So this is the mean of duplicacy. You can't choose duplicate array. Okay, so there is a multiple method to solve this question, but we will use optimization method. So what we can do, we can solve this by the help of backtracking. So initially, let's say our sum would be 0, I can say, and we have given an array, same array, I can say 2 3 6 7. It is our initial array and our target would be 7. This is our target. So what we can do, we can make an list also which contain all the element which we have. So initially we have 0 sum in our function and our pointer would point to the 0 index. When we add 0th index element to our current sum, it would be 2. Again we call recursive, we call the function again. Again our pointer would be same here. Note it would be not shift forward because we can use this number to unlimited time. That's why our pointer remains same. So what we can do, we can again add 2 to the current sum, which will be 4. Again we call recursion. It would be 6. But again it would be 8. From here we are backtrack because our sum is greater than target. And whenever we call from here, it is always greater than that. We cannot achieve target because our number in the array are always positive, it is not negative. So we are backtrack from here. After backtracking, our pointer shift from here to here. Now the sum would be 9. It is as usual greater, so we will backtrack also from here because our current sum is greater than target. Now our pointer shift from here to here. It would again be 12. Again we backtrack from here and our pointer shift from here to here. Again we would add 7 and we go 13. We would again backtrack from here as well. So after backtracking from here, we initially backtrack from here without finding any subarray, or we can say any set of any set of number in array. So whenever we backtrack from here, then our pointer would be point here, because initially at 4 it is here and at here, and by backtracking it would be here. So when we add 4 to 3, that would be 7. And whenever our sum is equal to target, what we can need to do, we need to add all the element. We need to add all the element, our answer list. Let's say we have answer list, so we would add all the element which we contain in our list. I will tell you the code, but every time we add element our list, suppose that here we add 2, here we again add 2, and here we add again 2, like this, and here we again 2. But whenever we backtrack from here, we delete this element, and whenever we reach here we would have 3. So this is our list, and we add this list in our answer, I can say. Okay, and we backtrack from here. Again we have some call here also, and at the end there is one subset also which would directly contain 7, like this. This is an index. We have different call from 3 as well, and from 3 we would have 6. From 6 also we have different call, like this is for 2, this is for 3, this is for 6, this is for 7, and it is as usual equal. So we again add this element and we backtrack from here. So now let's try to look how our code will look like. So it is look like, suppose we have a function, f1, and in this function we have an array which we get from the question, like this is our array, and we can say this is ARR, and we would also receive target, whatever target we require. And one current thing we mentioned, it is current sum, whatever the current sum we have. Initially we have 0, and after that we have an list also which contain the element which we have. If you use this C++, you can use vector definitely. This would be integer type, and we can name it as answer. From here it is, we can say current index. Initially it would be also 0, it would be null initially, and these both things have mentioned in the question. So what our base condition would be? It would be if our, I can say, current sum equal to target, like we call from here, it is 2, 4, 6, 8, so it is greater than that. So what we do, we backtrack from here, we directly return from here. And if our, I can say, current sum equal to target, so what we can do, we also have an, I can say, you can also define a global list, or whether you can pass this list in the function which is equal to your answer, that is list, which is type also of list, which is integer type, and whatever you name it, like you have to name it your container, and this is equal to new, whatever the format you can use it. And if it is equal, like there from here it is equal to 7 by plusing 3, so whatever you can do, you can add this list in this list. So we can say container.add new array list, and we can add this. In C++ maybe a different format, so you can use format according to the language, and return from here. Why we return from here? Because there is no need to call from here, so we would actually return from here. Now we can make a for loop, and our initially pointer would be pointing to the this current index, and it is less than the, I can say, array dot length, then I plus plus, and we would add current element in this list, so we would add answer dot add, I can say, array I, and we can call the recursion call f1. We would call the same function, same target would be there, current sum would be current sum plus ARR of I, and your answer would be the same list, and your current index would be the same, it is I. because whenever you code like this is 2 2 3, like this is 2 3 6 7, if you are here, you again call recursion from here also, because you can use this infinite time. That's why we have I. But if you can use, if there is a constant in the question that you can use this digit only 1, so what you can do, you can call this I plus 1, but now I only. And you can backtrack from here as well, like we can answer dot remove, and it would be the whatever the size of answer dot size. You can remove the last element from here, and then you get your answer. I hope you understand this code very well. So we can say this is our first base case and this is our second. It is not a base case, it is our satisfy condition, and this is our, I can say, a main code. This is our main code, and from here we backtrack, and here we add the element in our list, and this is our recursion code. I hope you understand this very well. And the time complexity would be order of n to the n, n to the power n. I hope you can understand this very well. There is another method you can solve, like you can first sort this array in an order of n log n time. First sort this array, after then you can make a call and make a condition that if the current sum is greater than target, then there is no need to call further. So the average time complexity of this algorithm would definitely be better, and I hope you can try it. Thank you very much.